Imagine a metal so strong it can survive the fiery heat of a jet engine, yet light enough to be worn as a watch or a pair of glasses. A metal that never rusts, even in seawater, and is so safe that doctors place it inside the human body as implants. This is titanium. But here's the twist. For most of human history, no one even knew it existed. Hidden deep inside black sand and ordinary rocks, titanium remained a mystery until the late 1700s. And even after it was discovered, it took more than a century before humans figured out how to unlock its power. Today, titanium is everywhere, in airplanes, spacecraft, submarines, medical tools, bicycles, and even sunscreen. Yet behind this everyday presence lies a fascinating story of discovery, struggle, and innovation. So how did this extraordinary metal go from invisible sand to the backbone of modern technology? Let's uncover the surprising history and production of titanium.
In the year 1791, in the quiet countryside of Cornwall, England, a clergyman named William Gregor noticed something unusual. While studying black sand near a stream, he found it was heavy, magnetic, and unlike anything he had seen before. When he tested it, the sand revealed traces of a completely new element. Gregor named his discovery Monacanite, after his village of Monacan. But at the time, almost no one paid attention. A few years later, in 1795, the German chemist Martin Heinrich Klaproth rediscovered this mysterious element. Realizing its potential strength, he gave it a new name, titanium, after the Titans, the powerful giants of Greek mythology. The name was fitting. This new element promised incredible power. But there was one problem. It was locked tightly inside minerals, impossible to extract in pure form. For more than a century, titanium remained just an idea, a curiosity of science, a sleeping giant of the metal world.
Unlike gold or silver, titanium is never found in pure form in nature. Instead, it hides inside stubborn minerals like rutile and ilmenite. At first glance, these look like nothing more than ordinary sand and rock, but deep within them lies one of the strongest metals on Earth. The problem? Titanium doesn't want to come out. The moment it's heated, it reacts fiercely with oxygen, turning brittle and useless. Throughout the 1800s, scientists tried again and again to isolate pure titanium. But no matter what method they used, the results were always the same: small, fragile pieces that crumbled in their hands. For more than a century, titanium remained an untamed metal, impossible to control. It wasn't until the 1940s that a breakthrough finally arrived. A metallurgist named William Justin Kroll developed a method to extract titanium using magnesium in a controlled environment. This technique, known as the Kroll process, changed everything. For the first time, titanium could be produced on a large scale. The sleeping giant of metals was finally awakened.
To understand how titanium is made, we have to start at the very beginning, with the Earth itself. Titanium doesn't come out of the ground as shiny metal. It begins its journey locked inside minerals, mainly rutile and ilmenite. These can be found in huge deposits in countries like Australia, South Africa, and Canada, where mining companies dig up sand and rock that look ordinary but hide something extraordinary. Once the ore is collected, it goes through its first transformation. Scientists treat it with chlorine and carbon at high temperatures. The result is a clear liquid compound called titanium tetrachloride, or TiCl4. It looks harmless, but it's highly reactive and must be handled with extreme care. The next stage is where the magic happens. Using the Kroll process, this titanium tetrachloride is heated with magnesium inside a sealed chamber. Out of this chemical reaction comes a strange porous material known as titanium sponge. It's not yet the sleek metal we recognize, but it is pure titanium in its raw form. Finally, the sponge is melted in massive vacuum furnaces to drive out any oxygen or nitrogen. From there, it is cast and shaped into ingots, rods, sheets, or wires, the building blocks that industries around the world rely on. And here's a fun twist. The same titanium dioxide used in this process also shows up in everyday life. It's what makes your toothpaste white, your sunscreen protective, and your paint bright. Titanium doesn't just soar in spacecraft, it's sitting quietly on your bathroom shelf.
So, after all that effort, what makes titanium worth it? Why go through the trouble of mining, purifying, and melting this difficult metal? The answer lies in its extraordinary properties. First, titanium is incredibly strong, yet surprisingly light. It has almost the same strength as steel, but it weighs about 45% less. That means you get power without the burden of heavy weight, a game changer for airplanes, rockets, and even sports equipment. Second, titanium is resistant to rust and corrosion. While other metals weaken in rain or seawater, titanium stands firm. That's why submarines and naval ships rely on it to survive the punishing ocean environment. Third, titanium is biocompatible. The human body accepts it as if it were part of itself. Doctors use it for hip replacements, dental implants, and surgical tools because it doesn't cause allergic reactions or rejection. In other words, titanium can literally become part of you. And finally, titanium is heat resistant. It can endure temperatures that would melt or weaken most other metals. That's what makes it perfect for the blazing heat of jet engines and spacecraft. Put all of this together, and titanium isn't just another metal, it's a super metal, combining qualities that no other material can match.
Even with all its strengths, titanium still has one big challenge. It's expensive to produce. Mining, purifying, and processing require enormous effort, making titanium one of the pricier metals on the market. But researchers around the world are working to change that. New methods are being tested to make titanium production cheaper, cleaner, and more sustainable. If they succeed, we could see titanium move far beyond jets and implants. Imagine lighter cars that use less fuel, stronger buildings that last longer against the elements, or next-generation spacecraft built to push deeper into the solar system. Titanium's story isn't finished. In many ways, it's just beginning.
And that brings us to the end of our journey into the world of titanium. A metal that began as black sand in Cornwall, was named after the mighty titans of Greek mythology, and now powers everything from spacecraft to hip replacements. It's strong, light, rust-proof, and biocompatible. A super metal that continues to shape our present and our future. If you enjoyed uncovering this story, don't forget to like the video, share it with friends, and subscribe to Simple Things, Surprising Histories for more deep dives into the hidden stories behind everyday things. Because sometimes the most ordinary objects have the most extraordinary history.